Now, number 15 rather says that what the value of x, y, and z for respectively in the expression m raised by x, n raised by y, and t raised by z for the universal gravitational constant G, capital letter G, are dash. Now, what we're going to do first is what? Capital letter G is from the law of universal gravitational constant. We know the first universal law of universal gravitational constant, which says what the gravitational force is equal to Gm1 m2 over what? R squared. So this particular formula, if you make G the subject of formula, I want to have G equal to what? Force times what? R squared divided by what? M1, M2. And what is the dimension for force? Is ML, I told you to master it, minus 2. Then dimension for what? For distance square is L square. Then divide by what? M times M. This one will cancel this. So what we are going to have at the end of the day will now be what? ML minus 1. If this 1 goes up, become minus 1. L square times L is give us L cube. Then this one will give us T raised by minus 2. So the answer to that question, if you compare it with this one, M minus 1, L cube, and T minus 2, the answer is what? M is equal to minus, S is equal to minus 1, Y equals to 3, and Z equals to minus 2. So option A says what? 2 minus 3 minus 2. B says minus 1, 3 minus 2. C says what? Minus 1, 2 minus 3. D says what? Minus 2 minus 1, 3. So the answer should be what? Option B, which is minus 1, 3 minus 2. So option B is the answer. 16 says what? The dimension of ML square T minus 2. That one is very straightforward. Represent dash. A, momentum. B, power. C, work. D, pressure. The answer to that question, I think I've answered that question before. That should be what? The answer should be work done. So ML squared T minus 2 represents work done. I mean, the dimension of ML squared T minus 2 represents dash. A, momentum. B, power. C, work. And D, pressure. The answer to that question is work done. That is what we are going to number 17 now. Says what? Number 17 now. It said, which of the units of the following physical quantity are derived? Roman figure 1, area. Roman figure 2, thrust. Roman figure 3, pressure. Roman figure 4, mass. So those ones that are what? That are physical quantity that are derived are 1, 2, and 3. 1, 2, and 3. So the answer is option A. Say 1, 2, 3, and 4. B say 1, 2, and 3. Option B is the answer. C say 1, 2, and 4. D say 1 and 3. So the option B is the answer. Number 18 says what? Which of the following physical quantity are derived? Okay, we have answered that question before. I think that question was repeated. So the answer is still the same. Now, number 19 says what? Which of the following is derived unit? A, meter. B, coulombs. C, kilogram. D, seconds. The answer to that question is coulomb. Coulomb is the unit of charge. Coulomb is the unit. Let's go to the next one. Number 20. Number 20. So number 20 says, which of the following physical quantity? So don't forget, number 19 is what? Coulombs. Kilograms, seconds, and meters. Check all this analysis I've done. I believe you should be able to get that. Number 20 says what? It says, which of the following physical quantity is correct paired with what? It corresponding. Which of the following physical quantities is correctly paired with it corresponding? Roman figure 1, corresponding SI unit rather. Roman figure 1 is kilogram meter cube for density. No, density is kilogram per meter cube. Kilogram per meter cube, not kilogram meter cube. Number option B says what? Joules per second. Yes, that one is power. Joules per second is power. C says specific latent heat. Specific latent heat. Specific latent heat is what? C equal to heat over change in temperature times mass. So that should be joules per Kelvin per kilogram or per kilogram per Kelvin. So that's option C is joules per kilogram per Kelvin. Yes, correct. D says what? Pressure is what? Newton per meter. Newton per meter. No, pressure is not Newton per meter. Power is what? Joules work over time. B and D, latent heat. Okay, please don't forget that C, that B is not specific heat capacity, it's specific latent heat. That means joules per kilogram. Sorry for that. Per kilogram mass, which is L. Mass L equal to what? That means latent heat or specific latent heat equal to heat over mass. Sorry for that. That one is not correct. Joules per kilogram. Option C is not correct. Option D, pressure is what we yes, that one is not correct. So the only correct answer for that number 20 is what? Power, which is joules per second. Number 5, which of the following is not is a fundamental quantity? Speed is derived. Option A. B, density is derived. C, length is fundamental. D, impulse is what? Derived. So the answer is C. Number 20, what? We have 22. It said, which of the following unit is derived? A, kilogram, B, meter, C, Kelvin, and D, Newton. So the answer is Newton is derived. That means N. Number 23, it said, which of the following set of quantity is a fundamental? A, length, mass, and time. I think that is the answer. Can look other options, but that is the answer. Is fundamental. Number 24. He said the dimension of momentum. You have answered that question also. Dimension of momentum are dash. So the answer is what? ML T minus 1, which is C, is the answer to that question. ML kg meter per second. Kg meter per second. So it's what? If it's kg meter per second, so the unit will be MLT minus 1. That is momentum. So that is 24 for you. Number 25. He said what? Which of the following is a derived unit? A, ampere, B, kilogram, C, seconds, and D, ohms. So the answer is ohms. Ohms is unit of resistance. Ampere is for current, kilogram for mass, and so the only answer there is what? Is ohms, option D. Number 26. He said, which of the following properties of a steel bar can be measured in terms of dimension of length? Which of the following properties of a steel bar can be measured in terms of what? Dimension of length only. A says what? Weight. B says what? Density. C says pressure, and D says volume. Dimension of length only is volume, because volume is length times breadth times height. All of them are length measuring what? They are measured in meter. So that means they are telling you about the quantity that has only what? Units. That is length measuring what? Quantity. So that is volume is the answer option D. Number 27, he said what? Which of the following has the same unit as work as the moment of a force? The answer to that question is option C, which is work done. You don't need to question that. Number 27, he said what? Which of the following is the 27. Which of the following quantity or fundamental quantity? Which of the following is a fundamental quantity? A says what? Heat capacity. B, electric current. D, torque, and C, torque, and D, reactance. The answer is electric current. Number 28. In which of the following quantity has the same unit as energy? The energy is the same thing as work, which is option B. Then the last for number 29, which is what? Number 30 rather. Which of the following quantity is dimensionally independent? When I say dimensionally independent, means the units that what? Quantities without what? Without a unit. Dimensionally independent. Quantity without a unit. Number 1 is what? Roman figure 1 is what? Dielectric constant. Dielectric constant is a what? Is dimensionally what? dependent because it has a dimension. Now, if it has a dimension, that means it's what? Dimensionally what? Dependent. But then if you check, you can derive F equals to what? From Coulomb's law, equal to 1 over 4 pi epsilon naught times what? Q1, Q2 over R squared. This is the unit of what? The Coulomb's law. Then if you make what? Epsilon naught the subject of formula, what we are going to have is what? Q1, Q2 over R squared times F. So that means Coulomb square per meter per Newton is the unit of what? Dielectric constant. Dielectric constant. You can put it as what? Dielectric constant, which is what? K epsilon R. Dielectric constant is epsilon R. So if I say, sorry, the epsilon naught is permittivity of a free space. Dielectric constant is ER equals to dielectric of a medium. That means permittivity of a medium over permittivity of a what? Of a free space. That is the relationship between the permittivity of a medium and permittivity of a free space equal to dielectric constant, which is also known as relative permittivity. That one does not have a unit, sorry. Does not have a unit. It's only permittivity of free space and permittivity of medium that have a unit. Roman figure 1. Roman figure 2, momentum, it has a dimension now. Roman figure 3 is what? Dimensionless too. The dimensionless efficiency, it does not have a dimension, although it is measured in percentage, so you cannot really tell. Let's leave that one. But Roman figure 4, refractive index. I think the 1 and 4 are clearly option that we can take. But although the efficiency does not have a specific dimension, so it is dimensionally independent. Independent means to be free of something. So that means that 1, 3, and 4 could be better option for us. So option A is a 1 and 2, B is a 1, 2, 1, 3, and 4. I mean 2, 3, and 4. Option C is a 1, 2, 3, and 4. D is 1, 3, and 4. So I believe option D is the best answer for this question. Number 31, which is what? Which of the following unit is not fundamental? A, meter. B, second. B, kilogram. C, joules. D, candela. Joules is the answer, which is what? Not a fundamental. The joules is equivalent to 32. Joules is equivalent to dash. You can use kilogram meter square per second square. The second to last question said what? The unit of what? Of flux density. Flux density is the same thing as magnetic field, which is Tesla. Option A say Tesla. B, Weber, watt. C, say Newton per meter. And D, coulombs, which is what? The answer to that question is Tesla. Tesla is the answer, or Weber per meter square, which is flux density. Magnetic flux density. Magnetic flux is different from magnetic flux density. Magnetic flux is what? Phi equal to B. Magnetic field or flux density times what? Area. But this is magnetic flux. This is magnetic flux density. So this one is measured in Tesla or Weber per meter square, while magnetic flux is measured in Weber. So I will leave this one with you. The SI unit of inductance is dash. You type your answer and what? Send it to the comment section. A, Henry. B, Faraday. C, Henry. And D, Coulombs. Type your answer and send to us in the comment section. I remain Engineer Holiday. I'm done with the first part of measurement and unit question. Please ensure you watch the video to the end. Thank you. God bless you.